All right, ITS128, and today I'm just going to go through the Chapter 6 slides because you should be working on your midterm, and your midterm is due, I guess, next time, March 10th, and so it's due March 10th, but I'll accept it until March 17th. And if you still have problems after then, after that is spring break, and I'd be happy to meet with you during spring break. And I won't take points off. So, but it's not, the midterm should not be that difficult because I've given you a bunch of hints, and you can look at last Tuesday's video. So let me, I gotta share my screen. All right, so it's due the 10th, which is next Monday, I guess, and but you actually have till the 17th, and but starting next week, I'm just going to start doing some other. I'm going to start going to Chapter 7 and so on, or I guess it's Sunday. Start talking about arrays and lists. All right, so I think what I did briefly start talking about methods last time, but I forgot to share my screen, so probably wasn't too meaningful for you, unless you're here in class. So methods are just a way of encapsulating code that you're going to probably want to repeat or parameterize and use in more than one place. And so methods are pretty flexible. You can create methods that can appear inside expressions. Like you remember from math class, like the sine function or the square root function. Those are usually written as words, but they can appear right inside another expression with numbers around it. You can use methods that way, and you can pass parameters, pass arguments into methods, and there's a couple of different ways of passing those arguments. There's passing arguments by value and passing arguments by method or by reference, and I'll explain what all those mean. So methods can be used to break up a complex program into small manageable pieces, and we sometimes call this divide and conquer. Divide a big problem into smaller problems, and they're easier to solve, and then they add up to a larger solution. And so we call that modularization. And there's two types of methods. Well, there's more. One way of categorizing methods is methods that just simply execute a bunch of code, and when they're done executing, whatever variables or whatever were modified inside the method, are modified. And then there's also these value returning methods, which are what I just described, where those methods can be called when they're inside an expression, and so they're evaluated, and then the result will appear where the method sits. So, for example, here we have a example of a method that's just it's a void type method, which means it doesn't return anything. It just executes these statements, in line here. And then there's this is another example of where we have a program here, which in this example we're just supposed to be seeing that there's a bunch of statements here. There's 6 statements that are just executed by themselves inside this thing here, which is the button, my button click event handler. And what we can do is we can, you know, put like some of them in one method and the rest of them in another method. And then we can just call these methods just like we do here. And we see that that they're just executed in line. So void methods simply execute the statements, and then when it's done, it's done. It doesn't, quote, return any value. A method has 2 parts. It's got a header part and it's got a body. The body contains all the statements that are executed, and the header is sort of how it's defined and how it's called and whether or not it returns a value and whether or not there's parameters that are passed into it and all that. So here we have an example of a method, or the method header. There's different parts to it. There's what's called the access modifier, which is that says whether it's a private method or a public method. And a public method can be called by code that's outside, whereas a private is just able to be called by code that's inside the same class. And then there's a return type, which says whether it returns a value or not. And there's a name of a method. And then there's parentheses. And then there's and there can be parameters or values inside the parentheses. So for example, here's a method. It's a private method, which means it can only be called by code inside that surrounds it. It doesn't return anything. You'll see what that means more later. This is the name of the method. And then there are these parentheses, which indicate that it is a method. And if there's any parameters that get passed in, they get passed in inside the parentheses like this. Methods usually belong to a class, and in this particular, in ITS128, most or all of the methods are usually inside the Form 1 class. And so here's declaring a method inside of a class. They might be declared down here, underneath this stuff here. So here's an example. We have a go button click event handler, which is the event handler for a button. You click on the button and this thing executes. This thing right here executes. I'm going to switch over to slideshow, current slide, and I got to get a pen here I can write with. So this is the event handler for a button, a go button, and you click on the go button and this thing executes. And what this is this is an event, or this is a I'm sorry. This is a method which we've defined. It's defined right down here. It's called display message. And what display message does is when it's called, this thing executes. And all this does is display out a message box which says, this is the display message method. Okay, very simple just to illustrate how this works. Okay, so the concept of a return point. When calling a method, the system needs to know where the program should return after the method ends. The system saves the memory address of the location, and that's called the return point, which is where it should return. The system jumps to the method, executes the method, it executes the statements in the body, and then when it's done, it jumps back to the return point and resumes execution. So, for example, here, if there were any more statements right underneath here, then after this method is done executing, in other words, after this is done executing, then it would return back to this point and continue executing down. To modularize a program, programmers commonly use a technique called top-down design. Back in the old days, that's all there was. And so it breaks down an algorithm into methods. The overall task is broken down into a series of subtasks, and then the subtasks are examined to determine whether it can be further broken down into more subtasks, and we keep on doing that until we actually just code the subtasks. And ideally, we would like these methods to be no more than like a page, one screen, but that's not usually. Oftentimes they end up being longer than that. Okay, passing arguments to methods. So an argument is a piece of data that is passed into a method when the method is called. So in the following statement, this following statement calls message box. So this is a method. This is one of the built-in methods. MessageBox.show. We use that all the time. It's a method. It's a .NET. It's the show method of the MessageBox class. But this is a class that's provided to you within the .NET framework. So it's not like you have to write it or anything. It's just there for you. And then this is an argument that is passed into the show method of the MessageBox class. So and a parameter is a variable that receives an argument that is passed into the method. Okay, so when you're calling a method, here we are calling the show method in the MessageBox class. This thing right here, that is called an argument. Okay, inside, okay, here for example, okay, we have a method. It's called display value. That's the method. It's the method we've created, and inside this method that we've created, by the way, it's a private method. Doesn't return anything. The name of it is display value, and here's the parentheses. And then there's this thing, and so this is a different perspective. See, this is inside the method. This is where we are writing the method. This is called a parameter. So this is the display value method that we've defined, and we accept a parameter. And the parameter down here, this is what it does. We take that parameter, we take value, which is this, and we convert it to a string, and we display it out using this MessageBox.show method. Okay, so this is kind of confusing because it's methods defining methods and so on. But the point is that inside the method, we call this a parameter. Outside the method, we call it an argument. So here is an example of where we are calling this method. Okay, here we're calling it. So this here, since we're calling it, this is called an argument. The argument is 5. And so what happens is this is called, then this is executed, and this 5 comes in here, this parameter of 5 comes in here and it's displayed out. Okay, so just remember, on the outside, when you call the method, this is called an argument. On the inside, when you're defining the method and you're figuring out what happens with these arguments that come in, inside they're called parameters. contents of variables as arguments. Okay, so you can pass the contents of variables as arguments. You can pass variables, in other words. So here is this method that we've defined. Basically, it takes an integer value and just displays it out. It displays it out in a message box. That's all this simple, dumb little method does. Okay. Here, for example, what this is telling us is that the argument. See, this is the definition of the method. This is how we call the method. When we are passing an argument into our method, this can be a variable, it can be an expression, or it can be just be a value itself. You know, we can just pass in a 5 if we want to, and it works. So if we pass in an expression, this expression is calculated, and then that's what's passed in. That's what comes in as the parameter. The argument, when we're calling this method, is called, the argument is x times 4. The parameter, which comes in, is going to be whatever x times 4 is, which I guess is 20 in this case. The value is an int parameter in the display value method. In this example, x is an int variable with the value 5, and then it's passed, and the contents are passed in as an argument. The expression 5 times 4 is 20 produces an int result, and that gets passed in as an argument. Here's another example where this is an expression. We're taking the string of 7 followed by the 7 character followed by the 0 character followed by the 0 character. It's a string. It's 3 characters long. We're converting it to an integer, and then we're passing that in as an argument. Okay. An argument's data type must be assignment compatible with the receiving parameters type. So the argument must be assignment compatible, which means it has to be compatible like when you would do an assignment statement. And you know, so when you do an assignment statement, you know, sometimes the values don't have to be exactly correct. They don't have to be exactly the same, but they have to be like compatible. Like there's some of the number types you can mix up a little bit. Like if you're passing in a string argument, it's got to be a string parameter on the to accept it. If you're passing in an integer argument into integer parameters, you can pass an integer argument into an integer parameter, but you cannot pass a double or a decimal argument into an integer parameter. So the argument, you know, when you're calling the method, if the parameter is looking for, if the method is, as it's defined, is looking for an integer parameter, you cannot pass in a double argument or a decimal argument. If the method is defined as being able to accept double parameters, then you can pass in as an argument. Of course, you can pass in a double argument, but you can also pass in an int argument, because int is assignment compatible with double. In other words, you can have some double variable, double x equals 5. That works. This is an integer. So that's assignment compatible. That's what we mean by that. You can pass either a decimal or int argument in as a decimal parameter also, but you cannot pass a double argument into a decimal parameter. So if you have int I equals 5, you can say double x equals I. Let me erase this. You can say double x equals I. That's because it's assignment compatible. There's no confusion here. The reason you cannot do doubles and decimals is because the range is much different. The double range can be the numbers that can be stored in a double variable can be really big and really small, whereas in decimal, it's not quite as big, it's not quite as small, but it's way more accurate. So if you want real accuracy, you use decimal parameters. If you want really a wide range, you use double parameters. Okay, and you can also pass multiple arguments. See, this is confusing here because this is actually a method itself. But here we're passing in two arguments. And here we're passing in two arguments. So, and this is the definition. We've got this method called showmax, which I presume shows what the maximum of the two arguments, and it takes in two parameters. So when you call it, you pass in two arguments. When you're passing in arguments here, they're passed in order. Inside the showmax method, the first parameter that comes in other words, the first argument, is going to be called num1. It's going to be referred to as num1. The second one is going to be referred to as num2. So they're passed in order. So value 1 gets passed in as num1, and value 2 gets passed in as num2. See? But you don't have to do it that way. If you want, you can name the parameters, name the arguments. So out here, and you have to use the same names as what the parameters are called. So so here inside show name, inside the method, we've got one parameter called first name, and we have another parameter called last name. And let's say that when we call that method, let's say we want to pass the arguments in a different order. Well, we can do that, but we have to say which is which. So in this case, we're going to pass in Smith as the last name. We're going to pass in the argument Smith as the last name parameter, and we're going to pass in the argument Suzanne as the first name parameter. So in this case, it's, you know, this one goes in there and this one goes in there. That's perfectly legal to do. Otherwise, okay, so in this case, since it's right in order, then Suzanne is going to get passed in as a first name, and Smith is going to get passed in as a last name, since it's in order. Since we don't name the parameters here, we just pass them in the order. We can have default arguments, and when we have default arguments, we have to, defaults are defined in the definition of the method. So it's down in here, and you know we have to say what the number type is. We're passing numbers. What the type is, and if we want a default, then we can just do this. And so we have the ones that are defaulted afterwards. So we call it like this. We're passing in show tax, and we're passing in, this is the first one, which is the price that corresponds to that one. And there's no second argument, and so the default is gonna be used. Here, the default is not used. Here we actually pass in a tax rate, which is different than the default tax rate. So you can do it that way. All right, so here we're passing these by value. So whatever we're passing in values here. So we can have expressions, we can have variables, we can just have numbers, and it's passed in by, those numbers are passed in, and these variable names are used to refer to them. When we pass by reference, we aren't passing in a number, we're passing in a memory address that corresponds, that points, or that a memory address which contains a number. And so passing by reference, we put this ref thing in front of it. And so we, so here, let's say we call this by saying, okay, here's an example. Well, okay, so we, let's say we call this, we say set to 0 x. And up above here we say x equals 5. Okay, and then we say set to 0 x. Well, if we were calling this by value, so in here, here we refer to it as number. So if we were calling it by value like we do up here, then it's going to come in as 5 because this is 5, it sets 5. And then down here we set it equal to 0. And then when we're done, on the outside here, x is still 5. Okay, that's calling by value. But calling by reference, we aren't actually passing in 5, we're passing in x. So here, this is just like x now. And here we set x equal to 0. So when we're done with this, then x now is equal to 0. So it actually changes. It actually changes it. So when we pass by reference, we're actually passing the variable. We're actually passing the memory location of where 5 is, but we're able to change it. So it becomes a reference to the argument. And we have to use this ref keyword here. That's what this ref keyword is. So to call a method that has a reference parameter, you also use the keyword ref. Okay, so here we have int myvar equals 99, and then when we're calling it, we also indicate that we're calling it by reference. So when we pass the argument, we actually say ref. So now if we do message box, it's going to display out 0 because this would set it equal to 0. Whereas if we were not passing it by reference, if we were instead passing it by value, then show would still show that it's 99, even though inside we set it to 0. Output parameters are similar to reference parameters, except for we aren't passing in anything. We're only letting the method change a value that's coming back out again. So the argument does not have to be a value before it doesn't have to have a value before it's passed in, but the method itself is going to write something to it, and then when it's done, it's going to have, it'll have the value that the outside code can use. And if we do, The try parse. You know, we use try parse. That is there. We use out. Out. We have an out parameter. So here we aren't passing in anything, but we are passing out something. Okay, here's what called value returning methods. And it's kind of like using out, except for this whole thing itself is like the out. And of course, we're used to this because we use these methods all the time. Our parse methods are that way, where it takes in a string as an argument, does some conversion, converts it into a number, and then it actually returns a value. So this now takes on that value, and we're able to use that as a number to assign a variable to it, or we can actually use it inside of an expression. So we could do something like, let me erase this. So we could do something like int parse 100 plus 5, and now number is going to equal this is going to equal 105, because this can be used inside this expression. So we're able to write our own value returning functions, and the way we do it is, instead of putting the word void here, we put what the type is, and so it can be int or double or string or anything else. And here we have to have this return statement. We have to have a return statement, and this expression, whatever that is, has got to evaluate to the type that's defined right here. So if this is int, then this expression has got to evaluate to an integer. If this is string, then this thing has got to evaluate to a string. The access modifier, of course, can still be private or public. The data type has got to be something that we know, and there's a bunch more. And then there's the method name. We still have the same thing, the method name. We still have the parameter list, optional parameter list, and this return value, and then this expression has got to be a value, which is the value that this method name is going to take on when it's inside the code. The return statement is how you pass that back. So here in this dumb little method here, we're passing, it's an integer method. So it takes in two integer arguments, and this return is going to be this expression. It returns the value that this evaluates to. And so now if we do int j equals sum parentheses 5, 2, then j is going to equal 7. If we say sum this plus 10, then j is going to equal 17. Notice that the return value and the method type must match. So here we were defining a method here called sum, like we did before. Here we're defining a double. Here we're defining decimal. Returning values to variables. So a value returning method returns a value with a specific type. However, method no longer keeps the value once it's returned. So you can declare a variable to hold the return value to use over and over again. So here we've defined an integer variable called combined age, And this is going to be, this is a method that we use, and it's going to return an integer value, which is presumably this plus this. This is what the method looks like. And so after this code is executed, this thing combine age is going to store the value, but this no longer stores the value. So that's the only point here. There's Boolean methods. It's just returns a true or false. And do we do this? We do error checking, or we do input validation? This is a method here which is going to return whether or not this number is even or odd. So so we start out by declaring a variable called number is even, and we take the modulo operation. We divide the number by 2, and when we divide the number by 2, we take the remainder. We have a number, we divide it by 2 and take the remainder. The remainder is either going to be 0 or 1. That's what modulo does. That's what this operator does. It's going to return the remainder. If the remainder is 0, we know the number is even. If the remainder is 1, we know the number is odd. So this checks to see if the remainder is 0. If it is, we set this number is even Boolean variable to true, because it is in fact even. Otherwise, we set the thing to false because it's not even. And then we return that Boolean variable. And so now this thing takes on the value of whatever, what the Boolean variable is. And we could have also just done, these are other ways we could have done it. We could also say, we could have instead said, well, yeah, never mind. Okay, so with this code, the int value is assigned to a number. Parameter will be evaluated by an if statement. The return statement will return whether it's true or false, using the modulus operator in Boolean expressions. So the book discusses the use of the modulus operator to determine whether a whole number is even or odd. This thing. The modulus operator is useful for this. Yeah, okay. Possible values 0, 1. So here's a couple of ways of doing it. You can say if it's equal to 0, then we return this. You can also just return. You could say return return number mod 2 equals 0. This expression will be true or false. So anyway, here's another way you can do it. Use switch. So this is going to evaluate to 0 or 1. If it's 0, it's going to return true. If it's 1, it's going to return false. You can return strings, of course. Here's an example of where we're returning a string, and the name of the method is full name, and it's going to pass in 3 arguments or 3 parameters, a first, a middle, and a last, 3 strings, and here we just concatenate them together with spaces in the middle, and that's what we return. So this is going to return Lynn, Alicia, McCormick with spaces in between. Um, uh, this this textbook goes into a little bit of debugging, and we have the step into command and the step into command allows you to single step through a method. This you execute it by pressing the F11 key. We can select debug from the menu bar. See if I can. Tutorial 6.6 demonstrates the step into command. Do I include that here? Let me see. 128 resources. Tutorial 3.6. Yes, this thing. Let me see if it's So if you go to here and you go to resources, you click this tutorial 3-6. This is the tutorial that if you bought a textbook, you bought the textbook, you have this in here. If you are using an older edition of the textbook, then you do not have this in here. And this is a tutorial which actually takes you through and explains how these breakpoints work. And so, do I include this kind of sample programs here? Chapter 3. You'll download this thing here. So many programs here. What's this? Text box demo. Why it's not asking me to sign in? This is different. 'All right, so let me close this, open this up, and look at the code. What does this do? Just displays that out. Let me string name equals that. Let me throw in another text box. Okay, this one's called name text box. This one's called text box 1, and this one's called text box 2. Well, that's appropriate. So I just modified this a little bit, and I'm going to say string name equals text box text 1. Name plus equals space plus text box 1 dot text. Name plus equals plus text box 2 text. And then this text box is called output. Oh, it's a label. It's not a text box. Okay. Output label text equals name. Okay, so I'm going to put a breakpoint right, I don't know, here. And so let me start this up. And I can do Richard Peyton Alverson. And let me click on this read input. And this is where it stops. It stops at this breakpoint. And so we see name down here. Name is equal to Richard. Name text box is equal to Richard. Text box 1 is equal to Peyton. And what's locals? All right, so so now I'm gonna click this F. Okay, so I can do step into F11, click, and now it's clicked to the next statement. You see, and so now we see name is equal to Richard Peyton, and we see text box 2 is equal to Halverson. Then I can hit F11 again, F11. Now name is equal to Richard Peyton Halverson because I've added that on there. And text is still equal to, text box 2 is a text thing, it's equal to Halverson. And then I can do one more time, and we're done, and we see that output label is equal to Richard Peyton Halverson, and now we're down here. So that's a way to step through your program and to help you debug. And so now it's done and it looks like that. So if you want, you can go through this. Where is it? PDF someplace. Oh, here. This tutorial, and it explains, the different features of setting breakpoints and stepping through your program. And I don't use this very much. I would rather throw in message boxes around the place. It seems like I have more control. And lots of times I think you may find in the future you may be writing code and debugging your code in places where you don't have this fancy integrated development environment. Like, for example, if you're making a web page and you're writing your code in Python or you're writing it in PHP or something, you're not going to have this fancy integrated development environment. You're just going to be writing code, and your code's not going to work, and you're not going to be able to quite figure out where it doesn't work. So you're going to throw in places along the way to display out stuff, and that way you kind of have a little bit more. You're sort of more in touch with your program, I guess. But you know, if you find yourself developing large chunks of code and you're always going to be using Visual Studio, then it's worthwhile to learn how to take advantage of these. And you are able to see you're able to see all of these intermediate. You're able to see this stuff down here, where it actually displays the contents of all the different. You're able to set variables in here to watch. You can set these watch variables, and as you step through, you can see the values. I'm not doing this right, but and also with these, you're able to step over. In other words, let's say you've got some methods in there, and you don't care about what's going on inside the method. You just want to you want to see, what's some code execute, and then the method executes, and you don't need to go inside the method, but you want to see what happens after the method's done. These different ways of stepping over and stepping out and stepping through sort of add flexibility there. So that can be worthwhile. This tutorial, showing how to use these breakpoints and so on. This was just added in the last edition of this textbook. So it's not it's not super important, but it's a valuable thing to know how to use and do. So anyway, that's pretty much all I have today. And so you can finish up your midterm, and so try to finish by Monday and Sunday. And I'm gonna move on and talk about arrays next week. But of course, if you still have questions on your midterm, you can ask me. The real due date is the 17th, which is the day before, which is the starting of spring break. And if you still have problems with it, then we can meet during spring break here, and because I'll be around, and we can get you through it. All right, are there any questions? Okay, thanks for watching.